We are doing sequences, L'Hopital's rule, part 1. So we will find the limit of certain sequences using L'Hopital's rule in part 1, and then in part 2 we will do some more difficult examples. So as you can see here, a sequence is denoted by, the sequence AN is denoted by either this form or your normal brackets, which just means your sequence will be A1, A2, A3. So if I have to sketch a sequence on the Cartesian plane, I will have my n on the x-axis, my an on the y-axis. So for instance, if I have my sequence 1 over n, just note that n will go from n1 to n equals infinity. That's why we denote a sequence like that. So in this example, 1 over n, if n is 1, an is 1. If n is 2, an is a half, substituting it there. If n is 3, an is a third, and so on. So you can see that this sequence is approaching 0. But we cannot always see immediately what a sequence is approaching to, and that's why in this part we will introduce L'Hopital's rule. Now, do not confuse a sequence with a series. Later on we will do videos about series. A series now is when I add all these terms. So we've just said we're going to find the limit of a sequence. Now, if we get a number L, we will say that that sequence is convergent. If we get infinity or negative infinity, we will say the sequence is divergent. But more on that later. So do not confuse a sequence and a series. We know that this sequence limit is 0. Later on, we want to see whether or not this series is convergent or divergent. So it means when I keep on adding the terms in this sequence, for instance, let's do this one first, or the terms in the series, I get 1 plus a half plus a third plus a quarter, and so on. Later on, we do various tests to see whether or not the series is convergent, and then we will, for instance, see that this series is divergent. It means when we keep on adding, we will just go bigger and bigger and bigger. The sum will not get closer to a number. So that later on in our videos about series. But since we're going to do L'Hopital's rule in this video, it's very important that a sequence is not continuous. So how do we see that? Remember, my sequence that I drew here, there are only dots. I did not draw a continuous function everywhere where that function is defined. So I have these gaps, which means that my sequence is not continuous. And because in L'Hopital's rule we use the derivative, and we can only do the derivative when a function is continuous, that's why in L'Hopital's rule we will change to a function. Very, very important. Now, what are we going to do? I hope all of you know your limit laws by now. I did paste it here for convenience, but this is all from first year. So if my one sequence approaches L, my other sequence approaches M, then the sum or the difference will approach L plus M or L minus M. If I have a constant, I can take it outside. The limit of a product of a limit, and so on. So you can study all these that I've pasted here, and then we will use them later on. Now, very important, L'Hôpital's rule. So where lots of students go wrong, students think that there are only 2 forms for L'Hôpital, because in first year you often get to use these 2 forms, 0 over 0 and infinity over infinity in L'Hôpital. Students mistakenly think that those are the only forms of L'Hôpital. But what they actually have to know that there are 7 forms. So there we'll get 0 over 0, then plus or minus infinity over infinity. Now, very important, infinity minus infinity, 0 times infinity are also forms of L'Hôpital. So are my 3 exponential forms. So we'll do examples on this, more on that later. Just please remember that there are 7 forms of L'Hôpital. What do I mean by that? So if I check x approaches c or any number, and I get that fx approaches infinity, gx approaches infinity, I get infinity over infinity, which is one of my forms. What do we do in L'Hôpital? We derive the numerator, we derive the denominator. If we still get infinity over infinity or L'Hôpital form, we will derive again. If we get a number, that will be our answer. Now, a common mistake is that students think they have to derive this whole fraction, so they use the quotient rule. Please focus on that and be wary not to make the same mistake. It's not the quotient rule, it is deriving numerator and denominator separately. Then I've just pasted some of these limits here. I will just now mention what is important there, and then by now you should be all acquainted to your Lin laws. Very important. Now, this is what I want to stress. This is your Lin graph, so it will just continue. It will be a continuous function that as x approaches infinity, it will go slow and slow and slow to infinity. That's why we say the range are all real values. Then our exponential graph, e to the x, very important is this one. So as x approaches infinity, we will just continue indefinitely. So all these are extremely important, and like I always mention, I suggest that you study all your theory first before attempting the examples. So you can all see there is quite a bit of theory before you start. Then obviously, because when we do L'Hôpital and we get one of the 7 forms, what L'Hôpital rule is actually saying, that you derive top and derive bottom. So hence, what are we working with? We're working with derivatives. Hence the reason why I did paste the table of derivatives. Make sure you know your table, your product rule, your quotient rule, your chain rule, and then the derivatives of all your trig function, the derivatives of your hyperbolic functions, and then also these 4 extremely important. More on that later. What I just want to stress, this flow diagram is going to be extremely important for what's coming, the 7 forms of L'Hôpital. If we get these 2 forms in pink, indicated in pink, we have our fractions, and we will then straight go to L'Hôpital. More on that later. But if we have the two forms in green, in other words, infinity minus infinity or 0 times infinity, just do not just assume your answer is 0. You will do L'Hopital. But to be able to use L'Hopital, we always need to change into fractions. How will we change that into a fraction? We will get an LCD, more on that later. How do we change a product into a fraction? We will say a over b to the minus 1, which is a over 1 over b. Very important for later. Common mistake students make. They do not know, for instance, let me just use an example. If I x times e to the x, how can I change it into a fraction? It is the same as e to the x over 1 over x. But more on that later. Then what's going to be very important, but I'll do an example. When we have these three forms, the exponential forms, 1 to infinity, 0 to 0, 0 to infinity, we will always use this. Ln y is equal, limit x approaches infinity, of ln fx to the power of m. Because what will happen then? The m, because of our ln laws, will go to the front. Now what do we see here? We're going to change that into a fraction, which is ln f of x over 1 over m, what I said earlier, then L'Hopital. But more on this as we continue with examples. So let's do our first example. They say evaluate. So what the question will be in your section, it will actually be the sequence. But since you get as n approaches, this should be 0, 0 for instance. So you will, for instance, get e to the 0, which is 1 minus 1, 0. N approaches in 0 at the bottom, 0. And you know that is a L'Hopital form, and therefore you will change to a function. Very important. So this part you should just do in rough, because we never substitute. Because if we substitute n at the bottom, it's undefined. It's just approaching 0. Now, since it's 0 over 0, it is our pink form, the fraction form. It is in terms of a fraction. What are we going to do immediately? We're going to derive top, derive bottom. The derivative of e to the 2x, 2e to the 2x, derivative of x is 1. Now we can substitute. So what do we have? X is 0, so e to 0 is 1. So our answer is just 2. And hence the reason why I said you must really know your derivatives. Let's look at the next one. So what will happen somewhere in the test? You have to do this limit. What do you see? Ln to infinity. Hence why I said these tables, these graphs are very important. If I say x approaches infinity of ln x, I hope you can all see, it will be infinity. So what do I see? I see here I have infinity over infinity. Do not substitute infinity in. We never in maths do that. We just mention, and you can even do it roughly, that therefore you will use L'Hopital's rule. So now you derive the top, derive bottom. You know your derivatives. Derivative of ln x is 1 over x. Now a very important fact that I want you all to make sure, also a common pitfall when students do this, as x approaches infinity, 1 over x, the bottom is getting bigger and bigger. The top stays constant. So the bigger the bottom, you will get a very small fraction. This will approach 0, no matter what the constant is there. Let's go quickly to our next form. So what will happen again in a test somewhere? You have this, e to the negative n times square root n. So what you have to do, since it's not continuous, before L'Hopital you change to a function. But what do you see? E to the negative x will approach 0. Why? Let's look at the sketch. Please remember from now on, e to the negative x is the reflection of e to the x in the y-axis. So it is our blue graph, and as x approaches infinity, it will approach 0. So therefore, this will approach 0. Our root x, as x approaches infinity, just remember it is this graph, a graph that we use often, and it will approach infinity. So we have 0 times infinity, 0 times infinity, which is a L'Hopital form. Do not say it is 0. Now, what did I do here? So we've done the pink, we're on the green now. So for these two, you have to change to a fraction. If you change to a fraction, if it was this form, you get the LCD. This form, we change the product to a fraction. That is definitely a common pitfall. So how do you change that to a fraction? You know from school, e to the negative will go to the bottom. From school, you know, if you have a negative exponent, you take it into the denominator, it is positive. Now what do you see? You have infinity over infinity. So just to recap, you will see we use these often. There is my e to the x. And then if I replace x with negative x, it's the reflection in the line y equals y. It's a reflection in the y-axis, e to the negative x. So just make sure you know the limits here. So what do I do now? I do derivative of the top, which is, what is my derivative of my top? It is 1 over 2 root x. My derivative of bottom, e to the x. Now, also common mistake, students normally struggle with this, but this is actually from school. So a over b over c, you can just drop that to the bottom. It's a over bc. So this is what I did there. Please remember in maths, also students, as a mistake students make often, they want to do that limit immediately. No, never do a limit before you have simplified completely. And we never leave a fraction inside a fraction. That is not the simplest form. I always just want to get the one fraction. So I get that. What do I see? I see that my bottom, it's infinity times infinity, which is infinity, 1 over infinity. Like I said earlier, if the denominator is getting bigger, the fraction is getting smaller. So, very important, all those facts that I have mentioned now. Now the next one, we see you have x approaches 0 from the right of sine. Here's our sine graph from the right. That will be 0. So we get 0, and then we have the exponent x to the right will just be 0. So you don't have to write 0 from the right and 0 from the right. You can just say 0 up to the power of 0, which you know is an indeterminate form. So it's one of your 7 forms. So you will use L'Hôpital. Now this is very important what I'm going to do here. Remember what I said earlier? Let's just recap the very important flow diagram. We've done our one pink one. We have done one green one. Now we're on the purple. For these two exponential forms, we will always go back to this form. We will write ln y is the limit as x approaches infinity of ln fx to the m, so that we can use the limit law. So let's do it here now, since we have one of our exponential forms. So I have ln y is ln of my limit. So there I've just done both steps, because remember in maths I will ln both sides, but I know that the lim of a limit is the limit of a ln. So I can take this actually inside. Now I have my ln law. When I have an exponent here, what do? I take it to the front. That's why I said make sure you know your ln laws. So I did paste it here. So you must also study that before you start with the examples. The exponent goes to the front. So now, very important, and like I also said, I hope you know your derivatives, because as you've noticed, we use a lot of derivatives. Now I'm here. Just look at the purple. I have done this part now. Now I must change it to a fraction. So this factor will go to the bottom. And we will say m to the minus 1. So let's see what we will do here. Our x will go to the bottom, 1 over x, to get the L'Hôpital form. Now I have a fraction. Whenever I have a fraction, and I know because I have a fraction, I will actually have infinity over infinity. Why is that? I know as x approaches 0 from the right, my sign will approach 0, and then ln of 0 will approach negative infinity. There is my ln graph. So as x approach 0, my ln graph will approach negative infinity. That's why I have negative infinity over infinity. Just remember, for L'Hôpital, you can get any sign, plus or minus infinity over infinity. It does not matter what your sign is. Now I derive my derivative of ln sine x. I always see that even at this stage, that students do not know what this derivative is. So by now you should know it's f prime x over fx. If you do these questions and you realize you do not know your derivatives, please do not continue with examples. First go back and study the table. So that's why I got here the derivative of ln sine x. Derivative of sine x is cos x over sine x, and then derivative of 1 over x, negative 1 over x squared. Now, just to stress what I've said earlier, before you do a limit, never just do it from this fraction. Why not? Because I have fractions inside a fraction. You need to simplify. From school, you know that you have to tip and times. And for that part, let me just make sure you know that. So for that part, you will tip and times. You will get the limit as x approaches 0. You will get cos x over sine x times by negative x squared over 1. But you know that this cos over sine is cot, and cot is 1 over tan. So please remember all your trigonometry from school. Now we have again the orbital. Why? Because as x approaches 0 from the right, our parabola will approach 0. Our tan graph will approach 0. So what do I have to do now? I have to derive again. Derivative of negative x squared is minus 2x. Derivative of tan x, sec squared x. So by now, you do understand that derivatives are extremely important. I get it a lot that students get to this stage and they don't even know what the derivative of tan x is, and then they cannot continue. Now just make sure when I'm at that stage, I have negative 2x over sec squared x. This will approach 0. Now, if you're not sure what the sketch for sec squared or sec look like, rather always change your sec to 1 over cos. Sec is the reciprocal of cos. So I have cos squared x. And you know in trigonometry, we always put the exponent on the outside. Now, what do we know about our cos graph? That's please make 100% sure you know your sine, cos, and tan graph very well. So, as x is approaching 0 from the right, you will get 1. So, here you get 1. So, sec squared, the limit as x approaches 0 from the right of sec squared is 1. Hence, we have 0 over 1 and we get 0. But now, a common pitfall, please do not make this mistake. Remember, we are trying to solve ln y because I want you to remember to bring this down all the way. Now you have ln y is 0. Ln y is 0. And also something that students are not always familiar with, let me just write it here. If you have ln y is k and you want to put it in exponential form, you always say y is e to the k. Just make 100% sure that you're familiar with that. Hence, I have y is e to the 0, which is 1. And therefore, my limit is 1. Why? Because this was equal to y, and I have just solved y. So, like I said, that is a common pitfall. Students will just leave their answer at 0. No, you need to bring this down and remember that ln of y is 0, then solve y. Now, in the next video, L'Hopital's rule part 2, I will discuss some of these exercises. So before you look at the video part 2, I want you to make 100% sure that you know, number 1, your theory from this video very well, and then do my examples again that I've done. And then thirdly, you can start with these 10 exercises, and then I will discuss some of them in part 2. Obviously, we don't have time to do all of them, but we will do some of them in part 2. And this is the end of L'Hopital's rule part 1.